Good day, viewers all over the world. You are welcome to Toydel Online Class. Today, we want to look at the type 2 types of partial fraction. That is when we have repeated factors at the denominator. Either the factors are linear or non-linear. So this is the type 2 repeated factors at the denominator. So how do we resolve this into a sum of its partial fraction? Then this is what we do. We're going to write 2x plus 3 all over x squared into bracket x plus 3 squared. So how do we resolve this? We pick the first one, say maybe a all over, the first one is, you have x squared here. You first pick x plus, you go ahead and do b all over x squared. So we've resolved this first one. We go to the second one. We're going to have plus c all over x plus 3, then plus d all over x plus 3 all squared. So when we have repeated factors, if it is x cubed, we are going to do it from 1 x squared up to x cubed. So this is how to resolve this into this is how to rewrite this into sum of its partial fraction. Then if you now multiply through by the denominator of the left hand side, at the end of the day, we are going to have 2x plus 3 here, which will be equivalent or equal to, if x you multiply x here, we are going to have a x into bracket x plus 3 all squared plus, when we use x squared to multiply what you have here, we are going to have b into bracket x plus 3 all squared, then plus we have c x squared into bracket x plus 3, then plus d x squared. This is what we are going to have. So if you use the left hand side, the denominator of the left hand side to multiply through, that is what we are going to have. So at this point now, once we get to this stage, then we can now resolve this. We can now use a method of resolution. Either we use cover-up method or comparing coefficient. But in this case now, we can use cover-up method. If I put x, I say put x is equal to 0. That is, if I say x equal to 0, I'm going to have 2 into bracket 0 here plus 3 to be equal to, if I put x equal to 0 here, since this is 0, everything here will vanish. If I put x equal to 0 here, I'm going to have b into bracket 0 plus 3 all squared. If I put x equal to 0 here, since this is x squared, everything will vanish. X equal to 0 here, everything will vanish. So this is what I'm going to get. So here I'm going to have 3 all over 3 squared is 9, so it's equal to 9b. If I divide both sides by 9, at the end of the day, I'm going to get b to be equal to 1 over 3. This is what I'll get. I'll get b to be equal to 1 over 3. Then also, if I put x equal to minus 3, there will be some cancellation. This is what I'm saying. Say also put x is equal to minus 3. So if you consider this equation, I'm going to have 2 into brackets minus 3 plus 3 to be equal to, if x is equal to minus 3 here, minus 3 plus 3 will be 0. Everything will vanish here. Minus 3 plus 3 will be 0. Everything will vanish here. Minus 3 plus 3 will be 0. Everything will vanish here. We only have d into bracket minus 3 all squared. Then at the end of the day, 2 times minus 3, that's minus 6. Minus 6 plus 3, I will have minus 3 to be equal to 9d. If I divide both sides by 9, then I'm going to get d to be equal to minus 1 over 3. So we have gotten the value of b, and we have also gotten the value of d. So we have gotten the value of b and d. So we can go ahead. We have gotten the value of b and d. So we can go ahead and solve for a and c. So we have gotten that here from here. So since we have done that, we have gotten that. So I can now, let me write it somewhere. We have gotten the value of b to be equal to 1 over 3 and d to be equal to minus 1 over 3. So I can clean this. Let me clean this and see what can be done to be able to find the value of the remaining two. Okay, what to find for a and c. So these are when x equal to 0 and x equal to minus 3. That's what we do. I can also assume, I can say put x is equal to minus 1. If I substitute x equal to minus 1 in this equation, what will happen? I'm going to have 2 into bracket minus 1 plus 3 to be equal to a. I'll do it directly. If x equal to minus 1 here, I'm going to have minus 1 plus 3. That's 3 minus 1. That's 2. 2 squared is 4. 4 times minus 1 minus 4. So I'm going to get minus 4a here. Minus 4a. Then if I come to this side, this is minus 1. 3 minus 1, 2. That is 3 minus 1, 2. 2 squared, 4. I'll get plus 4b. Then if I go to c, this is minus 1. Minus 1 times minus 1. That will be 1. 3 minus 1 is 2. I'm going to have plus 2c. Then I come to this last one. Minus 1 squared, that's 1, plus d. Okay, that's what I'm going to have. So at the end of the day, I'm going to have minus 4a plus 4b plus 2c plus d to be equal to 3 minus 2 to be equal to 1. I can call that one equation 1. I can call that equation 1. So I've gotten a particular equation for that. I can call that equation 1. Then I will look for another value. I can say put s. Just to have two equations, I can also say put s to be equal to 1. So if I put s to be equal to 1, so that I'll be able to get two equations, then by the time I substitute value of b and d, this equation will be reduced to two unknown. Then I can solve the equation simultaneously. If I say put s equal to 1, then I'm going to have 2 into bracket 1 plus 3 to be equal to, if x is equal to 1 here, I will have 1 plus 3, that is 4. 4 squared is 16. So I'm going to have 16a plus, if s is equal to 1 here, plus 16b, then s is equal to 1 here, 1 plus 3, that's 4. 4c plus 4c plus 4c, then plus, if s is equal to 1, it will be plus d. So at the end of the day, I will have 16a plus 16b plus 4c plus d to be equal to 5, equation 2. So there are two equations here. Since we have two equations here, these two equations now has 4 unknown. But by the time we substitute for b is equal to 1 over 3 and d equal to minus 2 and minus 1 over 3, we are going to reduce this equation. So if we do that, then this is what we get. If you do that correctly, then we are going to get, if we substitute in this equation 1 and equation 2, if I substitute for b to be equal to 1 over 3, I'm going to get minus 4. I'll get minus 4a plus 4 all over 3, okay, plus 2c. Then if I substitute for d equal to minus 1 over 3, minus 1 over 3 is equal to 1. Then if I reduce that, I'll get minus 4a plus 2c to be equal to 1 plus 1 over 3 minus 4 all over 3. So if I find the LCM will be 3. So I'm going to have 3 plus 1 minus 4. And at the end of the day, I'll have 4 minus 4. 4 minus 4 is equal to 0. Here will be 0. So I'm going to have minus 4a plus 2c to be equal to 0, equation 3. So when I substitute for the value of b and d in equation 1, I was able to get equation 3. I'll go ahead also to substitute the value of b and d to equation 2 and see what I'm going to get. So if I substitute, I'm going to have 16a plus 16 all over 3 if I substitute for b plus 4c, then minus 1 all over 3 is equal to 5. That's what I'm going to get. So I will have 16a plus 4c to be equal to 5 minus 16 over 3 plus 1 all over 3. So if I find the LCM, that will be 3. So if I 1 and 3, that's 3 times 3, I'm going to have 15 minus 16 plus 1. So that's the 16 minus 16. 16 minus 3 is going to give me 0. So at the end of the day, I'm going to have 16a plus 4c to be equal to 0 as equation 4. But of course, I can divide through by 2. So that at the end of the day, I'm going to have 8a plus 2c to be equal to 0, equation 4. So if I solve equation 3 and equation 4 simultaneously, plus 2c equal to 0, equation 3. If I solve these two equations simultaneously, I'm going to get 0. Because if I say equation 3 minus equation 4, equation 3 or equation 4 minus equation 3, that is 12a, 2c minus 2c equal to 0. Therefore, a is equal to 0. So I've gotten the value of a to be equal to 0. If a is equal to 0, I can substitute. If a is equal to 0, I can substitute. If a is equal to 0, I can say substitute a equal to 0 into equation 3. Then if I do that, I'm going to have 0 plus 2c equal to 0. C will also be equal to 0. So C is equal to 0. So I've gotten the value of all the unknown in the question. Since I've gotten the value of all the unknown, then I can go ahead and write the answer out correctly. That is, here I have 2x plus 3 all over x squared plus x plus 3 squared. That's x plus 3 squared. You know, we write this as a over x plus b over x squared plus c over x plus 3, then plus d all over x plus 3 all squared. So if I substitute the value of a is 0 all over x plus b is minus 1 over 3, that will be 1 all over 3 into bracket x, 3 into 3 all over x squared, then plus c all over c plus x plus 3, then minus this minus that's minus 1 all over x plus 3 all squared. So finally, we are going to have the sum of its partial fraction to be 1 all over 3x squared minus 1 all over 3 minus 1 over x plus 3 all squared. That is what we are going to get as the final answer if you look at it very well. So the sum of its partial fraction, the sum of its partial fraction is what we have on the board, and that is what we are required to do. Thank you.